Assalamualaikum. So let's solve this October 2023 question number 12, which is from the chapter Momentum. So let's solve this question. In the question, they have said a teacher demonstrated the principle of conservation of linear momentum using two gliders A and B and on an air track. It has the same mass as B, so the gliders, both the gliders have the same mass. A and B were initially stationary, then A was pushed gently towards B as shown. State the principle of conservation of momentum. We all know the conservation of momentum states that total momentum before a collision needs to be equal to the total momentum after the collision, provided that there are no external forces acting on the system. So let's write it down. It's an O level type question. This type of questions usually come in O level. So let's write it down. Total momentum before the collision Okay, so we are done with question number A. So let's move forward and solve the question number B. In the question number B, they have said a magnet was attached to each glider. So there was a magnet in glider A and there was a magnet in glider B. Okay, there was magnets attached to glider A and B. A data logger, the gliders collided and stuck together. So they stuck together after the collision. They become one single body. After the collision, they become one single body. As they collided and stick together, after the collision, they began as one single body. They become a one single body. A data logger and sensor were used to record the velocity of A. The velocity recorded after the collision was half the velocity recorded before the collision. Okay, the velocity was halved after the collision. Deduce whether these results show the law of conservation of linear momentum. Okay, so we all know the law of linear momentum says momentum is going to be equals to mass into velocity of both the gliders. Momentum is equal to mass into velocity. So as after the collision, both the glider became one single body. As they stuck together, their mass becomes doubled. Their mass become doubled. So as their mass become doubled, the velocity will be halved. So this result show that this results shows that the law of conservation of linear momentum is obeyed. So we can write it down in our own words and say that yes, it was completely all right, the thing that has happened. So let's go and write it down. We can write it down in such a way that momentum is mass into velocity, and after the collision, the mass that is moving is double the original value, because velocity is half its original value. The velocity becomes halved. Momentum remains the same, the law is obeyed. The law is obeyed. So we are done with solving two straight questions. This was quite straightforward. Actually, these are O-level stuff. So let's move forward to this question, which is going to be a bit difficult because the previous two questions were really easy. So let's move forward and solve it. They have said, explain why the force of attraction between the two magnets did not affect this demonstration. So the thing they have asking us is, why did the force of attraction between these two magnets did not affect the demonstration? First of all, one thing that I want to mention to you guys is that the force of attraction between these two magnets are internal forces. They are internal forces. They are in between the system. And the principle of conservation of linear momentum says no external forces acting on the system. So these are internal forces. These are not external forces. So as long as the internal forces are acting, there is no issues with the law of conservation of momentum or the principle of conservation of linear momentum. So this is one point that we have got, and we have to mention another point from these 2 marks in order to get the whole marks. So let's go and look at the question to a more closer way. In a more closer way, we can see one thing, that is the force of attraction. They have said the force of attraction. This glider is having a force in this position, in the right, and this glider B will have a force in the opposite direction according to Newton's third law pair forces. They are third law pair forces. As the magnets are in this position and in this position, the magnets will attract each other, right? These are attraction forces. So this will act in the opposite direction, but the magnitude of the forces will be similar. As they are acting in the opposite directions, suppose there is a force of 10 Newton in this position and there is a force of 10 Newton in this position. It will be minus 10 Newton and it will be 10 Newton. So the resultant force will be 10 Newton plus minus 10 Newton, which will be overall 0. So there is no resultant force. As there is no resultant force, these two magnets, the force of attraction between the two magnets did not affect the demonstration. There is no resultant force, and if there was a resultant force, it would have still not affect this demonstration, because these are all internal forces. So we can mention these two things, that the glider A and B are accelerating in opposite directions. So let's go and write it down. The gliders accelerate in opposite direction because the magnetic force are equal in size. They both are equal and are acting in the opposite direction, and opposite in direction. They are equal but acting in the opposite direction. So the resultant force is 0. So the resultant force on the system is 0. And another thing that you can mention is the magnetic forces are not external forces. These are the 3 points that you can learn from this. Though they have asked for 2 points, this was optional, but I have still I want you guys to remember this, because you never know, maybe in your exam day this similar question may arrive with 3 marks on it. So it's better to learn 1 or 2 more points, as it is colliding with our syllabus. So we are done with question number 12. Have a good day, guys.